Hello, everyone. My name is Fernando. I work as a consultant at Percona, which is a company that provides services and software on open source databases. Our products are open source. And I worked many years in the support department before joining consulting. And I learned so much in support, working with different problems, different cases. But this one that I'm going to discuss today is, in fact, inspired on a recent project that I worked with on Postgres. So the product that I was helping the customer with was a legacy application. And that application was mainly running on a main server, but it was also have data on a different server, and that data needed to be replicated. But they weren't using any sort of Postgres replication, no extension. They were just using stored procedures to do this replication between the two databases. There was also another server that was doing the same thing. And they approached Percona because they were having performance issues. And it was, when I started looking at it, and discussing with the customer, it was very different because, yeah, they had these particularities and everything, but there were days where there were no changes in the database whatsoever, right? And still, the server was super high load. And I used one tool that was developed by a colleague at Percona. His name is Jobin, and if you're curious, it creates like a fingerprint of your Postgres server and creates a HTML report out of that. Right? So it's really great to have just at a glance what's happening in the server and what is the configuration of the server, so you can just have an understanding. And right away, I noticed that the database size was not so small, but it was generating so many temporary tables. And that was when I realized that there was these stored procedures taking place all the time. And the problem was not just the load. The problem was that some of the stored procedures were failing. And so the whole replication thing was not working, right? And it was really affecting the business in the sense that they were approaching a moment they were having to stop what they were doing. And that would be a huge problem for them economically. So I just started discussing with my colleagues and think how many different ways we could do that, right? So for this project, I couldn't change a thing because it was a legacy application. They were, waiting for a certain period to replace that with something else. And I was thinking it's not often that we have the chance to discuss with a customer that is going to hire a different company to build your product, how it could have been made better, right? So this talk is a bit, it's an exercise in two things. One of them is the schema design for this kind of application. And the second one is bidirectional replication. And Postgres does not have bidirectional replication natively, as you know, but we can do it with logical replication, right? And yesterday, my colleague Robert gave a very nice presentation about that. Robert is really great. And I touch a little bit of some of the points he did, but I do it in a bit different way. So let's start. And I had to come up with a backstory for this presentation because I cannot disclose the customer, in fact, what he does, and So I came up with this idea for a space cruise ship because it's something that kind of filled the dots, as you are going to see later. And I'm kind of a laggard in terms of new technology, so I never really used AI to generate an image. So I tried, right, with ChatGPT, getting this concept of draw a space cruise ship, a small one. And that's what I got from ChatGPT and Canva. So I gave up using those images, and I went with clip arts I found on the internet, and they're credited in the end. So bear with me. This is the backstory for this presentation, how I build it, right? Someone has this idea for a space tourism, right? Someone then, you have people interested, they hop on a spaceship, do a little tour around the planetary system. There's a route for that. And someone buys the idea, goes, create a business, and people will start buying tickets, right? And when it comes to launch day, the passengers need to check in on the spaceship. And when they stop at some point and go off board, they need to check out, right? And the spaceship can only depart from this point when everybody is back in. So that's the backstory. When we are back on Earth, we do the final checkout. This trip is completed, right? So let's start thinking about a schema that could represent this. I focus on my schema around trip because that's at the center of that, right? For a trip, we need to have a route, and we also need a spaceship. We need spaceports where the ship goes in every stop. We need passengers, of course, and we need our registration system, right? That's how I call it the check-in system. So somebody surfing the internet, they find the announcement for the trip, and the trip has details around what is the route it's going to offer, what is the departure date, when it goes, and when it comes back, where the spaceport, where it launches, what's the return date, the return port, and the spaceship that is going to be used for this particular trip, right? And we are talking about a relational schema where we will have potentially many trips, not just one. So we also have an ID for this particular trip, okay? So we build the whole schema around that. We have the trip, we have the route with name, description, also an ID. Next, we have our spaceship with, again, name, an ID, and spaceport, name, an ID, maybe a location. And we have our passenger. And if you think about it, the passenger is a customer that's potentially coming back for other trips, right? So we should see it as they are. So they are a person, at least here on Earth, they are a person, right? And they have a name, an ID, and a birth date, and everything else. Address, whatever we want there, right? So a passenger is a passenger for a trip, right? And this passenger could have a role if you wanted to, and I took this out of the presentation because it became confusing. There's some confusing points that I still need to improve on this. But role would be the passenger is just like a customer or is part of the crew, right? So that was why it's there. An ID. And finally, we have our registration system. And the registration is for a passenger and a particular trip, right? Port, well, the passenger has the trip in here, in fact. Sorry. So the passenger, a date, a port where it does the check-in and check-out, right? And an ID again. So that's the schema as I saw it in the beginning of the project and how I try to implement the product around it. Okay? So if we want to visualize it around a Postgres schema, we have the usual fields that are described there. And ID here, I use it just as now to increment serial type, right? So just an integer here. So route, spaceship, spaceport, passenger, person, and registration. And for this example, I use it foreign keys to just have everything together, but this is not really necessary, right? Okay, so here's how I'm testing this schema. So I'm populating the tables, right? And I'm populating them just for one trip. That's our example trip here. So the first thing I do is I will insert spaceports. I will have one on Earth, one on Moon, and one on Mars. Okay. The second thing is a route. So I add a route that is that one that I just described at Earth, Mars, Moon, and back to Earth. Then a spaceship. I added two and gave them two names, Angie and Mabel. And first thing, I created a route, a trip with these details here, right? With a spaceport where it departs, where it comes back, the departure date, the arrival date, and a route, and a spaceship. So if we look at this particular trip as it is, there are no passengers, and it's just the trip as it is there, right? So next part for the demo, I start adding customers. So they go and purchase the ticket. So the first thing they do is they register in the company system as a person. They create an account, right? And here I'm creating 5 different people, 2 couples and 1 single passenger. And after I created this, I just added all of them as passengers of this example trip. Okay. So in the end, we have this trip with all these 5 passengers. If we want to see what is the status of the spaceship for this trip, there is nobody in there yet because it's not launch time, so it's not the day. But when the day for launch time comes, people start to show up and get on board the spaceship. So that's the first step of the registration. They are checking into the system. And here you will see for the checking field, I just used a Boolean, right? Either the person is in the spaceship or it's not. So when it gets, for the first check-in, this value becomes true. If it gets out, it's false. So everybody gets in, and we have everybody on board of this spaceship for this trip to start, right? So, and then you see everybody has check-in set to true. So imagine someone forgot his toothbrush and needs to get out of the spaceship, go to his car, and come back. So that person needs to do a checkout. It gets out of the spaceship. That same query will return false for this passenger to just check it out, right? So that's how it works. And the query, I just used the last value for this passenger. That's the status of his last value. So that's how we just know who is on board and who is not, right? So the only person off board with checking false is Lewis. And he gets back to the ship, and the ship is now complete and ready to depart, okay? So that's how it all starts. When we think about a system like that, you know, we think, well, I think at least on a client-server model, right? There is the spaceship doing all these registration things. It's connecting to a server. So imagine that we have a spaceship, which I took from Futurama, and we have a central where the database is, right? So every time that there is you are on the spaceship and you are doing a check-in or check-out, that is going to the database, to the table on the central database. Now, our first constraint for this project is what happens when the spaceship lands on Moon, right? And everybody is eager to go out and explore Moon, but then it tries to connect with the central, and there's just no signal, right? No connection. So this client-server model that does just not work for this business, because then nobody can get out of the spaceship. So if we use a streaming replication for that, we would have the whole schema on central, and we would have a copy of the schema on board the spaceship, right? With everybody that is registered to the trip is here as well. Except when we try to write to the registration, this is Postgres, you cannot, right? So this model doesn't work for this use case. But with logical replication, you can have the same thing. It's just implemented in a different way, right? You create a publication on your server, and then you reproduce the exact same schema on your client or on the subscriber of this publication inside the spaceship. We just recreate the schema and create a subscription where I'm copying all the data that is in here. It's going to be copied over here as well, right? So now I have, again, the exact same thing, but I can write to my registration table. Okay. There's one important detail about logical replication and the way we did. In fact, not the way we did it, in general. The problem is, the first time I'm going to try and check out a passenger in my spaceship, it's going to fail because of a duplicate key on my registration table. Remember, I used an auto-increment key, which is a serial. And the one characteristic of logical replication is that you replicate all the data inside the table, but you do not replicate other things like sequences. So it is actually trying to do an insert on ID 1, but that ID has been already taken on the server, right? Here it's 8, but I had 6 passengers. I did some tests, but so the ID is 8 on the table. And so I try to add an entry on ID 1, because in my local sequence of registration, it's starting from scratch, so it's 1, and it's taken already. So that doesn't work. What I could do is just figure out what is the next available ID, and just use that, right? So then I can work. But that's a solution that you cannot really scale, right? It's just not something you should invest on. So let's look for a different approach. If you review the schema as it is, all these steps here for the trip, for the passenger, the person, this all takes place on Earth, right? So this is the domain of the central. However, all the registration, it's related to the spaceship. So we could consider that everything that's written in here comes from the central, and everything that's written in here comes from the spaceship. Okay, so it's same schema, just a different way of seeing which part of it belongs to who. Okay. Okay. So we can redo logical replication, and so we just truncate the table, start again, drop the database, recreate it, recreate the schema. I'm doing exactly the same thing, creating a subscription for that publication we had created before, again with copy data true. And I can now do my registrations, check-in and check-out of the passengers here without a problem, right? Because I am doing from the beginning the first check-in on the spaceship, on the spaceport before it takes off. Okay. When I look at my central data, this data about the registration is not replicated here. And that's a problem because the central has no idea what's going on the spaceship, who is on board, who is not. So it's better because the spaceship can actually go and work, but the central has no idea of what's going on. So not yet what we need, right? So what we actually need is what I'm calling bidirectional replication. So for the spaceship, the spaceship has the domain of the registration table, but the central needs to be aware of what happens, even if it's not kind of synchronous, if there are intermittent connection between the two, right? Eventually, it will get that data. So we do what we did with the central. We create a publication on the spaceship just for the table registration. And the moment we start writing here, the central will also get the data. Okay. Now, let's leave that initial, let's call prototype aside, and just look at one of the problems that we have with bidirectional replication. which is called loops, right? Loops in bidirectional replication. What is this? So I'm using a test database here and creating just the registration process here, just part of what we were doing, right? This time I'm not adding any primary key just to make this example more straightforward. So I create a publication central, I create a publication spaceship, and I have that each one subscribed to the opposite publication, okay? So the table registration is replicated from both sides. So what happens when I do an insert on spaceship? That record, it goes to the central, but then it comes back to the central, to the spaceship, and gets replicated again in the central, and goes back to the registration, and that's the loop, okay? That's the loop. And the same thing happens on the spaceship, because here I did insert on the spaceship, it went to the central, it went back to the spaceship, and this is the infinite loop that we have. This is so easy to do without a primary key, because if we do with a primary key, it will happen what happened when I first try it. It will have a duplicate key, and that will break replication on the spot, right? Okay. By default, this field origin is set to any when we create a subscription. And what it means, I think we looked at in this example or in the next one. Yeah, I think we look at it in the next one. So let me just go back and just to have you remind that. This is the default field for this value. And it means that I am getting replicating events from my wall files, no matter where these events come from, right? That's why we have the loop. Okay. So let's start again. Drop these two subscriptions. And let's do it again with something that is new to PostgreSQL, which is another value for origin, which means none, right? So that's why we say bidirectional replication was made possible with changes that were done on PostgreSQL, because now besides of any, we have none. And when we do that, we do an insert on the spaceship, it gets to the central, but it doesn't come back and doesn't do that loop. Why is that? Because when I set origin to none, I am saying I only replicate events that are not coming from me, right? So how can we visualize that? That's part of the next text. Just keep that in mind. Any questions so far? It's okay? So second constraint of my project. Here I have my spaceship, first one for the first trip, Angie, and I have my central, right? Each one has a table, and this is being replicated both sides. In fact, it's missing an arrow here, there. But now I have a second spaceship, which is Mabel, which is taking care of other trips. So my fleet is increasing, right? And I also have a registration table on Mabel. And it also goes to the central and goes back to Mabel. So there's a bidirectional replication here as well. So multiple spaceships. How can I take care of this new constraint with the schema I already have? Remember that the solution I found for the other one was that I was going to just write registration from the spaceship perspective and not from the central. But now I have two spaceships writing on the same serial ID here. So we can always try to find a different primary key, right? And sometimes it's very straightforward. In this case, I could use just the passenger and the date, because the passenger ID is relative to a particular trip. So that's unique already. And what makes different check-in and check-outs entries in this table is the time it happens, because you can only do a check-in and a check-out. You cannot do multiple check-ins at exactly the same time. So I just changed my schema and used passenger date and registration date as my primary key. Okay, so that's what I have now in the new version of my schema, just this change. And now I can just redo the central, I can just redo the replication bidirectionally on both sides, right? So spaceship to central, central to spaceship, spaceship to spaceship 2 to central, and back to spaceship. So I'll now create a second publication for spaceship 2 here, and a subscription for it on central. Okay? So let's think about this, another constraint. That other constraint was kind of solved there. Not really, you see why, but here it comes. I have a situation where my spaceship is landed on Moon, and suddenly there is a young couple that approaches and was not on board of the ship and say, hey, can we get on board and just continue the trip with you? So we want to start our trip from here, okay? But so we call that mid-trip registration. And the problem is that the spaceship has no knowledge of those persons because they are not in the system. So they try to connect with the central to register them on the system, and they cannot, right? So it means that, well, it's not just the registration that should be something that the spaceship can do. The spaceship also needs to do person and passenger in order to get on board those other people mid-trip, okay? So, in fact, person and passenger, they are a domain that is shared between these two elements. It's just objects, right? So, with passenger, it's kind of easy because I can have the primary key the same way I had with registration. I can just use the person ID and the trip ID and create a new primary key for that. With person, it's a bit more complicated because I also have an ID, and I could potentially use the document ID as the primary key for this table, but that's a sensitive data. We should not be using that on a schema to identify someone along on other tables, right? So that's not a solution we would do. The easiest one, but not the one we could take. So, for person, we have the ID, which is, again, a serial type, integer with a sequence, and that's the status of the sequence. It starts with the ID with the 0 and goes to the maximum of this integer can take, right? So this is how the ID is handled as a sequence in the table. And right now, my last value for this ID is 5, because I had 5 passengers or 5 persons recorded in the system, right? So for my schema, when I look at this person ID sequence, let me just have a look at the time. Okay. Another way of looking at that sequence is this. Okay, so I need to register new passengers in my central, but now I have this new constraint that tells me that I also need to register persons from the spaceship mid-trips. So I could just continue using that sequence, but define that differently for each of my servers, okay? So for instance, I could, for the first spaceship, I could take some values for the other spaceship, other values. I could have some values reserved for other spaceships that will come, and let everything else for my central. So here's a way to do that, right? So I will just create the sequence on the database for Angie from 1 to 1,000, for Mabel 1001 to 2,000, and then for central I will take from 10,001 because I'm keeping this reserved here to the end. Okay, so that's a way to solve my third constraint, second constraint. It is continuing using the exact same schema, but when it comes time to define my sequence, that will be a different interval according to the server where I'm doing that. So let's go back to a test mode for using this approach with the 3 spaceships. Again, this is outside our production database, but I'm creating on test a sequence for person, and I'm using that sequence as the primary key for the table person. And I'm doing that on all 3 ships, but with different intervals for each of my servers. Okay, I create the publications. For the central, I need to subscribe to the publication of Angie, and for the publication of Mabel as well. And for the spaceships, I just need to subscribe to the publication of Central. Okay, and now I will use the 3 little pigs as an example here. So the first pig, the fiddler pig, is registered on Central, and the second pig is the fifer pig. It is registered on Angie, and the third one is the practical pig on Mabel. Okay, so back to this. Now we are going to look at pgwall. Pgwall is a tool that is part of Postgres that allows us to have a look of what's going on inside the wall records, right? So if we just look what's happening on the walls, how the replication is happening on each one of these servers, when we do the first insert on the central for the fiddler pig, what happens is that this is the transaction that shows up on the wall record of central, right? There is this commit here, but no record for where this transaction comes from. This is what we call the commit none. There is no record for where this is coming from, okay? But the same thing on my spaceship has, in fact, an origin recorded here. And for Angie, this server here is identified as node 1, okay? The same thing happens on Mabel. This is a transaction that is not coming from Mabel. It is being replicated, and it identifies it as coming from node 1, the central. So let's just identify this as our first insert. Now it comes the time to do the insert on Angie for the second pig, fifer pig. So on Angie, we will see the same thing. There is no origin for Angie because this insert is coming from itself. But when it gets replicated to central, we get origin set to none, okay? What about Mabel? Well, for some reason, that insert doesn't reach Mabel, okay? The same, so that's insert number 2, and now we do the insert on Mabel, and we get the same thing that we got from Angie. So no origin here. On central, it is replicating as origin node 1, and on Angie, we get nothing, right? So this is a current limitation of the system, because when we look at that, on central, I have everybody that has been inserted, all the 3 pigs. On Angie, I just got the pig that was registered on central, and the pig it was registered by itself on the same server. And on Mabel, the same thing. The pig that was recorded on central, and the pig that was recorded on Mabel, okay? So everything that is inserted on central gets replicated to Angie and Mabel. But when I do an insert on Angie, it only reaches central. It never reaches Mabel, right? And that's the same thing when I do an insert on Mabel. It reaches central, but doesn't reach Angie. I try a different options for origin in the different servers, right? And the one that got me closer to making it work was setting origin to none just on central and using the default of origin to any on Mabel. But so I did the 3 inserts. Look what happened. For the first one, no problem, it's coming from central. But when I do the insert on Angie, that insert gets committed on Angie. There is no identity. We know it coming from Angie itself because it doesn't have an origin field here. But it gets inserted and aborted, inserted and aborted, inserted and aborted. That's our replication loop that we saw earlier taking place here, right? What is interesting is that when I do the insert on, it reaches Mabel, because for Mabel, it is coming from node 1 as well, so it's coming from central. So it has, it has an origin that is not itself, right? So that's insert number 2. And when I do the same insert on Mabel, well, I got exact same thing that happened with Angie. And if I look at what is my list of persons on all the 3 servers, it's a bit different of what we had before. On Central, we have all the 3. On Angie, we only have the one that was inserted on Central and by itself. And on Mabel, we have the 3 of them. But we have the 3 of them just because the last one was done by Mabel itself. And if we check the state of the replication, it is broken on the 2 spaceships. Just, it broken on Angie first because I run the second insert on Angie, right? And it breaks because of the primary key again, right? It's trying to reinsert an entry that is already there. The same thing, it breaks with Mabel for the same reason, just a different item, okay? End of the second test. So, for this mid-trip registration, I'm just doing the change of the primary key on passenger, person, and trip. And for person, we are using the same approach we used on the test, right? Which was altering the primary key. This is just showing the process I did to alter the primary key for you to use person and trip instead of ID. And implementing the same, this is, oh, sorry, too fast. This is the state of the sequence on Central as it was before. And implementing the same thing we did on test here. Except that since we already had passengers with IDs 1 to 5, I just started my sequence on a different point for Angie, right? Instead of starting on 1, I'm starting on 1,000. Because this is a production database, I'm making changes. I just cannot rewrite what has been done already, right? So I'm just using different intervals for my sequences. Okay, so Central starts on 1, Angie, that's doing the changes live on each server, right? Modifying the sequence. So now I can just come on Angie and do the insert for the new passengers and get them registered for this trip here, and finally get them on board. So I solve my third constraint, except that these passengers, I will have them on my spaceship records, I will have them on my central records, but I will not have them on my second spaceship records. Okay, so here's the list of passengers on Angie now. Now, constraint 4 is changing trips. So let's just imagine we stop on Earth. Both spaceships are on Earth. I have my list of passengers here. 2 of them get off board, the Jetson couple, and they have a fight. And the wife says, no, you don't come back with us. You take the other car, except the other car is a spaceship, right? No big deal. George is happy. He just knocks on the door of Mabel. Mabel sees him on the list of contacts here, just register it as a passenger of its trip. And the wife gets back to Angie, and George, sorry, this is, yeah, it's missing one slide. No, it's here. Okay, registration. Okay, George gets on board of Mabel. Jane. Jane gets back on board to Angie. right? And this is the state of our registrations for each passenger per trip. Now we have, let's pretend it's just George on board of Mabel, right? We have George on board of Mabel showing up here. And for the other trip, he's showing as off, checked out. He's not there. That's on Central. On Angie, we get the same thing, except we do not get the registration that says George is now on board of Mabel, right? And Mabel doesn't have any idea of the check-in and check-outs that took place on Moon while we make those changes, except for the fact that it accepted George on board, so it got checked in. Now, if we try to do the same thing with the young couple that just got on board Angie and they decided they have a dispute and the same thing happens and they part ways, and the young man tries to get on board of Mabel. Well, Mabel doesn't have his contact on record. And if I try to add him on record, which I could, right? I could do it. But then when it gets to Central, I will have two Anakins recorded on my person table. So this is not yet ready. The only solution I could see for this to work is if he turned it up into Darth Vader right away, right? So we could have a different person created and he could have got on board. So this is a limitation of the current implementation as we see it in Postgres, right? It's already better than we had before because we found a way to get around the loop in the replication. But I'm also happy to work with other databases, right? And I know this is a Postgres conference, so bear with me. But how MySQL does this is it uses two settings to control that. The first one is log replica updates that says, what we have, in fact, is a cascading replication or a circular replication, right? Except I don't have a connection between the spaceships because I don't want that. So I just tell to the server that it should also add to its own binary logs all events that they got replicated from other servers from its primary. And the second thing, and the thing that is to me that have been working with this for so long, is that we have an ID for each MySQL server, right? So when we look at the binary logs, all the events that are recorded there, they are recorded with an ID, right? So here I reproduce the exact same topology that we had with logical replication on Postgres. And I could see well, this ID 100 is for my Central, so here's where I got my first, the fiddler pig. The server ID 200 is for Angie, so this is where the fifer pig comes from. And the ID 300 is for Mabel, where the practical pig is come from. So I'm replicating everything because I decided to add that to my configuration. And this is something that Postgres could do as well, right? The same way we added the none option on Postgres 16, we could make this more configurable and say, no, I not only want to replicate all or just those that doesn't come from me, I want to replicate these specific transactions coming from these specific servers, right? So something that could be done. Now, it's a very niche case, right, that we are just looking at. It just happened that I had this customer that actually needed that, and I decided to look into that. Another possibility, it's something that was implemented on Postgres 15, I think, is the merge, merge, I don't know if it's a function or a feature. I think it's more of a feature where I can find a way to try and consolidate records coming from different places, right? So this merge here, it replaced I'm so happy I'm on time. This possibilitated replacing several stored procedures just with this function here. But it's not something I explored, right? And this is my clip art credits, and we have 5 minutes for questions. Cool.
How much did it take?
What?
Why can't we create like bidirectional replication between Angie and Mabel?
I could have done that, but that would increase the complexity. I didn't want relationship between the spaceships. Yeah. The only relationship they should have was with Central. So if I had done that, it would have worked. Problem is, well, the use case doesn't allow that. And logical replication, it's much more fragile than it is streaming replication. So whenever you're using logical replication, you need to be much more careful. Because when it breaks, you need to manually make it work again, right? So something you want to avoid.
My second question, right, like is, it's kind of like a hub and spoke that you implemented, right? Like where like, I mean, you have these like systems on the edge and like you have this centralized server, right? Like this can extend to all those use cases. But coming to what you said, it's a very, logical replication is very fragile, right? Like, so what is the kind of monitoring that you set in place to, track this for the customer, right? Like any visibility into that?
We do, because we have system tables that tells you the state of the subscriptions. And when it breaks, it out shows on the log file, it stops working. The conciliation process, it depends on what you want to do, right? You might just say, nah, just skip that one and let's move on. But then it's very few cases where you could do that, right? It depends on how important your data is to consider something like this. So you could monitor the status of the replication to know if it's working or not. But then to make it working again, it depends. Right? Any other questions? Cool. Well, thank you.
Thank you.
Thank you. Oh.